All right, so last time we left off, we had just finished creating the schematic footprint for our motor controller. And this time we're going to be able to take this, add it to our schematic, finish up our schematic, and then get started on our PCB. So first thing you want to do is after we have this created, we're going to go back to projects, and there's a couple different ways we can add that schematic or that footprint symbol that we just created to our motor drivers. Here are the motor driver schematic symbol that we created last time, and if you double click on it and scroll down in the parameters, you'll notice that there's no footprints or anything here. So we can go ahead and click this and add it here. And then we need to browse and find the footprint that we just created. So we need to make sure that we're in that Phil's Lab footprint library, and then find the Power SOIC 8. So that's the one that we just created. Click OK. Click OK. And now we should have our schematic footprint associated with that that object there. So I'm also going to show you another method to add it, and that is in the PCB library documents, or the schematic symbol library documents. So this is where we created our schematic symbol for that specific chip, which I forget the name of. It is the DVR 82. I'm just going to copy that and go back to this and then search that up here. All right, so here's the schematic symbol that we created. And you'll notice that there's no footprint down here. So right here, this is where a footprint would be attached to it. That would essentially mean that the method that we just did and added the footprint, it would not update over here in this library. So we need to add it over here. That way, if we want to place it, every time it has that footprint. So it's the same exact method as before. We click OK, OK, and then we can save this, go back to over here, save this, and now both of them should have that schematic. Oh, no, this one doesn't have it because it essentially just needs to be reloaded in, so it still is using it without it. So if I go ahead and add it again, so now I just added it again. Now we should be able to see the footprint that is associated with it. So I'm going to kind of move that back to the same place. All right, so now we have our chips with the footprint that we created associated with them. The next thing that we're going to do is create the footprint and schematic symbol for our battery connector. If you remember, we talked about what hardware we needed to put on our PCB, and that included our connectors for the motor, the control, and we ended up kind of scratching the current sense portion of it. So remove that and remove the current sense. But essentially we just need it for the motor control and the or for the motors and to control the motors from like a microcontroller or something. So the battery is going to be kind of this battery that we looked at, and if you remember, it had a connector on it, that little yellow one right there, which we found out was a male XT30 connector, and that connector was a horizontal one. So this is the essentially, yeah, it looks like this. This is the connector. However, we need to find a data sheet for this connector, and try to create the schematic symbol for it. So I found one here that has the documentation regarding that specific connector, and this includes all the information we need to create the PCB footprint for this specific connector. So let's go ahead back to Altium and create that. So what's nice is that XT30, you'll notice that Phil's lab already has an XT30 connector, which is nice. However, if we double click it and open up the parameters, or the properties, we can see it's not the same type of connector. So, or it's not that horizontal one that we were looking at, but rather a vertical one. For ours, I want to do a vertical or the horizontal one, so we need to change up the and add another footprint, so we are not using this vertical one here. So we're going to use the same schematic symbol that we have here, except we're going to add a different PCB footprint to it. So I'm going to go into our PCB library, and I'm going to go ahead and add a new thing. And usually the first thing I do when I add a new footprint is I name it. So I'm going to go into the properties, footprint, and then I'm going to go ahead and name it, I'll paste that same one, XT30 PW-M horizontal. And the description, I'll leave it empty as is for right now. But let me save it real quick. All right. So after we named it, going to go ahead and start our PCB footprint for this. So if we go back to the data sheet that we had pulled up right here, we have the information regarding what it wants the footprint to look like. It looks like we have 2 small holes up here and then 2 bigger ones down here. Looks like those 2 small ones are just for those, like looks like little screws or little pegs to mount it in place for holding. And then these 2 right here are going to be our kind of actual connections for it. So so we essentially just need to create these 4 holes at the same size and at the same exact distance from everything. So I'm going to go back over to here, and let's look at creating the first part of it. So I'm going to add those two holes for the actual connections first. And to do that, we're going to be placing a pad. So go up here and place a pad, and it already comes out with a through hole pad like this. I'm going to increase my grid size just for the time being, and I'm going to place it right dead center in the middle. The reason I place it in the dead center in the middle is we need to make sure that we're getting the correct distances from everything. And so I personally just like doing stuff like this, just starting in the middle, so everything we can use this top corner kind of location based on this first one right here. We also have the dx and dy, which is the difference from the last thing you placed or clicked, or every time you click, it zeroes it out, and then it's measuring the distance from there. But before we kind of place any of the other ones, we need to match the hole size. So the hole size for these ones, it looks like, is 1.7, and for the units, most of these are going to be in millimeters. Personally, it might say it here and I just can't read it, but I'd assume that the units for all of these are in millimeters, unless otherwise stated. So the hole for this is going to be those two arrows kind of pointing into it. So it's going to be 1.7. Let's double click that pad that we just created, and let's go down here, and we have a couple different things. So the pad, so right here is where we can actually kind of change those sizes for stuff. And if you notice right here, it says hole. So that's the actual hole size right there. And if we go back to over here, it says we need it to be 1.7 millimeters. And if your units aren't already in millimeters, you can press, whoops. You should be able to press Q to change them. Yeah, that didn't save. So if I press Q and then open this back up, you notice everything is in mils, which is an imperial unit. But we want to use the metric units, so I'm going to press Q again. Whoops, I just named it QW. I'm going to press Q again, and then that should change your units to millimeters again. If for whatever reason that isn't working, you can also go into View and then Toggle Units. And that, by clicking that, you'll notice that all your units for everything switches to mils. But again, we want to keep everything in millimeters. All right, so the hole size was 1.7 millimeters. And then you'll notice the hole is now completely overpowered our copper area. So we also need to increase our copper as well. So if the hole size was 1.7, we could make it, a couple point millimeters bigger. So let's make it 2 millimeters. And oh, here it is. Right. And you'll notice everything is increasing around that. So now we increased our hole size and created a little copper area around it as well. So, I don't like how thin that copper is around the edges. So I'm going to do maybe 2.3. 0.3. Whoops, 0.3. Okay, so that looks a little bit better to me. So we need 2 of these holes, and so the first one is going to be there, and the next one is going to be placed 5 millimeters across from it. So oops. So let's go ahead and copy this. I'm just doing Control-C. And then the same as before, this is where it's copying from. So I'm just going to click dead center right there. Now I'm going to do Control-V. And we have this, this new one, but we want it to be exactly 5 millimeters from the other thing. If we want it to get exactly 5 millimeters, we want to use the grid to be able to kind of get to our destination. So if you press G on your keyboard, there's all these different grid spaces that you can use. So for example, if I do 1 millimeter, you'll notice that everything moves a little bit smoother. And as I go down, it'll even move very, very smooth at 0.025. But since it needs to be exactly 5 millimeters, I can use the biggest one of 2.5, and just move it across. And to just move something twice, I'm going to use the keypad and just have my arrow shifting, my right arrow, and I'm going to hit it twice. And then that should be 5 millimeters across from the other one. And we can confirm that if we look in the top left corner where we have our X and Y, my X is 5 and my Y is 0. And so we know that those are 5 millimeters apart. Or the last check that you could do is if you do Control M, this brings up the measure tool, and we can click the center of that one and the center of that one, and it tells us that the X distance is 5 millimeters and the Y is 0, which is the same as here. So those two are now created. The next thing that we want to do, to be able to, is it Shift C? Yes. So to get rid of any of those measurement things, you can you can hold Shift and then press C, and that will get rid of any of your kind of measurements that are stuck up there. So the next thing we want to do are add these two other little mounting holes right here. However, instead of using the pad like we just used, I'm going to be using the via. And the reason that we're using the different types of kind of things to create those is because this battery connector has essentially two connections, right? We have battery positive and battery negative. These other two things, nothing is going to connect to them. They're no connects. So we don't need those to be kind of any connections for them on our schematic symbol. So if we go here, so they're not gonna, essentially every time that you use a pad, there's going to be this designator for it right here, right? So for example, if I hit 1 here and 1 there and 2 there, 2. So now both of those have those designators of 1 and 2. You're like, okay, well, what are the purposes of those? Those are to be able to kind of connect back to that schematic footprint that you created and have those designators, one, connected to the designators on the schematic portion as well. So if we go ahead and open up our schematic library, and let's go ahead and look for that other XT30 one that we had right here. So you'll notice that, there is a 1 and a 2. It's kind of hard to see here, but there is a 1 and 2, and a 1 and a 2 here. So if we double click the pins here, then we have that designator 1, and right here is designator 2. So how do those kind of link to your PCB footprint? So if I go ahead and click designator 1, it might be hard to see, but that pin or that pad that has the designator 1 name is also highlighted there. Or if I click 2, the other one highlights. So those designators are very important for connecting your schematic symbol to your PCB footprint. However, in this example, we only need 2 of them. For these pads, they're not going to be any designators we need for them. So instead of using kind of those pads, we're instead going to be using a via, and those vias don't have designators. So I'm just going to kind of loosely place it right there, and then let's figure out the exact placement. So it looks like they are 10 millimeters up. And what is the X distance from these? So we might have to use this one. So they're 10 millimeters up and 11. So we might have to do a little bit of like pen and paper math here to try to figure out how far away this is from that one. We know it's 10 millimeters up, but I don't know how much in that X direction it is. So assuming that they have symmetry right down the middle, which it looks like it does, it has perfect symmetry right down the middle, and this one is 5 millimeters and this one is 11 millimeters, meaning that from the center right here, we have 2.5 millimeters here. And then from the center here, we would have 5.5 millimeters here. So we have 2.5 millimeters subtracted, or 5.5 millimeters for this one, subtracted by 2.5 millimeters from that one, which would give us 3. Is that right? Let me figure this out. So 5.5. So I have 11 divided by 2, which is 5.5. So 5.5 minus 2.5 is 3. Okay, yeah. So it looks like this one is 3 millimeters to the right and then 10 millimeters up. So let's do that. Let's come over here and we can grab this. However, we want to change our grid since we cannot get to 3 millimeters exactly with a grid space of 2.5. Let's reduce it to 1. And I'm going to I'm clicking and holding to drag it. And I move it right over the center of that one. And I'm going to move it 3 millimeters to the right. So 1, 2, 3, and then 10 millimeters up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And if we go ahead and click that one and put our mouse here, we can see that our DX is 3 millimeters and our DY is 10 millimeters, which is correct. So we could do the same for the other one, or we can kind of just copy it and do the same over here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so let's double check our measurements here. So I'm going to do Control M for measure. These ones are 11 across. These ones are 5 millimeters across. That's 3, and that's 10 millimeters. So I believe, let me double check the other side, make sure I didn't mess up. All right, cool. So we have all of our measurements correct for this. I'm going to do Shift C to get rid of our measurements. And the next thing we need to do is, I kind of forgot before, but we need to make sure that this is the correct hole size. So the hole size for these is 1 millimeter. So let's go ahead and double click the via. And then these ones are a little bit different. All it asks for is the diameter and hole size. So for this one, it needs to be 1 millimeter. And we don't need to worry too much about that copper pad around it, but just because, make it 1.4. So the hole size, 1 millimeter, change this to 1.4. All right, so now we have our schematic or our symbol kind of created, right? But we need to do a couple more things before we're finished here. So this would work. However, Altium has a couple nice things that we are able to add as well. So I would like to add this 3D footprint, or the 3D model of this as well, if I could. And a really great resource for that is Snap EDA. So down here, Snap EDA is a website that has a ton of schematic symbols and footprints created for you. I personally have used it in the past, but nowadays I kind of just create my own schematic footprints just because I would like to create my own so everything kind of just looks more consistent, since everyone has their own way of kind of doing things. And in my opinion, it doesn't take that long to create your own footprints and schematic symbols. However, this might have the 3D model right here, which is really nice. I would like to use the 3D model in Altium. So I'm just going to go ahead and download the 3D model. Yeah, okay, I gotta sign in. Oh, it's so slow right now. Okay, there it goes. So go ahead and download this 3D model. And you'll notice we have just downloaded a step file. So let's go back to Altium, and we're going to go ahead and import that step file we just downloaded. So once we have this, we can go ahead and click place, and then we're going to place a 3D body. And let's go to downloads. Hey, there it is. And go ahead and import this 3D model. So here it is. It does look a little off, but let's see what it looks like. So, oh, that's why. So I pressed 3 to go in that 3D zone. So we need to rotate this. Is that correct? Nope. So let's rotate the X. No, it'll be 90. Oh, the Y. I've never had this happen before. Oh, there we go. Boom. There's 180. Whoops. So let's, yeah, this looks good. All right. So now we kind of just need to line up the two. So the way I did the kind of changing everything was just opened up the properties by just double clicking it. And then I pressed 3 on the keypad to go into that 3D viewer. And then I was just kind of, editing the properties of this piece while I was doing that. And so for this part, I'm just going to kind of line everything up correctly. Looks like my grid spacing is a bit off. Let's get to a smaller grid spacing. And boom. And this is also another good kind of visual check to make sure that everything is lined up correctly. We can see that those holes are in the place we need them to be. So that looks really good. And the way I'm flipping it over is I'm pressing VB at the same time. And you can also move things around by holding shift and then right clicking any of these to kind of rotate around things. So now we have this schematic symbol or footprint created with the correct holes, as well as that 3D model that we just made, which is really sick. The last thing we want to do is add a mechanical layer outline. So this mechanical layer outline is going to be, if we look on the very bottom, this can be mechanical 13. Essentially, this just creates an outline on our board telling us where the part starts and ends. So this is important for when you're doing your PCB. You want to make sure that you don't want to put things too close to one another and they might interact with each other on board. So creating this mechanical like kind of outline layer is really important for making sure that you don't put things too close to one another. So I first went down and chose the layer as mechanical 13. And then next I'm just going to add a line. And I'm going to make a little outline around the guy. And I like making it a little bit of a bigger barrier. So that seems about good for our schematic or for our symbol footprint. So I'm going to go ahead and save this. And then I'm going to move back to our schematic library where earlier we looked up XT30, which was this, and we already had a nice, whoops, go back. We already had a nice schematic symbol created, and all we're going to be doing is adding a second footprint to it that we could choose from. One more thing I want to double check before we move forward. You'll notice in this one, the positive is the pin number 1 and the negative is pin number 2. And you can notice that there's kind of a slant on the negative. I want to kind of confirm that the one that we just did is the correct for this being positive and this being negative. And the way I'm going to do that is using this using the 3D model that we added in. Hopefully they have, yes. So the little one with a slant on it is connected to that one, and the one with a flat edge is connected to that one. And if we remember, that one should be pin 1 and the one with the slant is pin 2. So I just want to double check by, I'm going to select, yeah. No, it's just going to select the whole thing. But I believe that one is connected to the one on the right and that one's connected to the one on the left, which, adds up to here. So, yeah, that would be bad if we accidentally hooked up the positive to this one and the negative to that one. When we plugged in our system, everything would get fried because we did reverse voltage. But, all right, I'm just going to go ahead and save again. So these are things, you really need to make sure before you're moving forward. So I want to add the other footprint that we just created, which I believe I called it XT30 PW-M horizontal. So let's go ahead and add it. So now we have 2 different footprints we could choose, and we could do the same thing here. This one is connected to the positive, this one's connected to the negative. So we just have that other check to make sure that this is all correct. All right, so let's save this. Now that it's saved, we can go back to over here. And again, you'll notice that we only really have this footprint here. However, if we go ahead and delete it and add another one, here it is. Let's double click it and let's go ahead and now under the value, we can change our schematic footprint or our PCB footprint. So now we need to do our connections for that one, and I'm going to press X to shift it to flip it over this way, and then we have VM and ground that we need to connect to this guy. So VM just for V motor, and then I'm going to copy this one, paste down here for ground. And then again, Control W for wire. All right, so now we have our battery connection. The last thing that we need to do is go back to our system requirements, and we need our motor connections and control connections. So for these ones, we decided that we wanted to use 2.54 millimeter male header pins so we can plug it into a breadboard. If you're unfamiliar with what those are, they're essentially just these guys. I don't know if you've seen them before, but these are the exact spacing of a breadboard so they can plug right into it. And as well as these, but because it's the same spacing, we could also use these 2.54 millimeter JST connectors, which look like this. They look like that. And so it's roughly the same size for the hole. The only difference is that they're a little bit shorter, so it's just made for a connector and not to have a pin go into like a breadboard or something like that. So those are the two things that we decided to use, and we could use either or. However, there seems to be a good amount of these 2.5 millimeter header pin footprints out there that we're just going to kind of use for our advantage. So I'm just going to copy that. Actually, I'm going to type it in myself. So when I'll back on Altium, we're going to go to Panels and then Manufacturer Part Search. And over here, we can go ahead and type in 2.54 millimeter header. And then for the motors, we needed 2 pins because there's just that motor. There's only 2 sides for that motor. So I like the look of this one. So let's bring it in. So we could see that that symbol is active and there's not a red line through it, meaning that we could use this. So we can hopefully drag it in. If that's not working, we can right click it and then hit place. All right, there we go. So I'm going to make 2 of these, and I'm going to flip these ones around as well. So these are going to be connectors for our motors. And if you remember, our motors have these 2 things going to them. So we have motor 1, out 1, and out 2, and then motor 2, out 1, and out 2. So let's go ahead and add some wires here. And copy and paste those net labels. Whoops. All right. Now we only have one more connector to do, which is the control connector. And this should be 6 pin. But for the control connector, actually just disabled my touchpad. Hold up. All right, there we go. So for the control connector, we need 6 different things going to it. So we have VREF, which is shared between both motor controllers. We have motor 1 in 1 and motor 1 in 2, which is not shared between both. This is motor 2, this is motor 1. So we have 1, 2, 3, 4, 5, and then we also have ground shared between them. So 6. So 6 pins in total. And I'm just going to do the same thing I did before and just look up 2.54 millimeter header 6 pin. And that doesn't look correct because there's 6 contacts in 2 rows. We just want 1 row. Here we go. So 6 contacts, 1 row. And they are 0.1 inches, which is equal to 2.54 millimeters. Altium's lagging. There we go. Oh. All right. And if you don't remember, again, why we're using 2.54 millimeters, that is just because breadboard spacing is 0.1 inches or 2.54 millimeters. So we could make this to be able to, this PCB be able to just plug straight into a breadboard. So we have this one over here. And again, we need VREF, motor 1 in 1, motor 1 in 2, motor 1 in 1, motor 2 in 1, motor 2 in 2, and ground. So I'm going to have VREF be at the top, and yeah, sure, I'll do ground at the bottom. And this is kind of arbitrary. You can kind of have any of those pins be anything you really want. There is some things to take into consideration when you're doing these, and you can always kind of Google kind of what's the best format. For example, if you have something that's more sensitive or has a lot of power, you can kind of figure out, or you can kind of Google and look around to see kind of which order makes the most sense. So for things that are sensitive, it's a good idea to surround them with grounds. But for our purposes, it doesn't really matter. I'm going to do up here, and I'm just going to change the direction it's facing just because I want it to be like that. Add a little wire. All right, and then we also have that motor right there. Matter of fact, I think I'm going to change VREF to be a power style port. I kind of like that idea more. So let's go bar style 4. And again, it doesn't really change anything. It's just visually, since this is like a voltage, like a supply voltage or a reference voltage, I'm going to use the kind of correct schematic symbol, but again, it doesn't really change anything. It's just visually pleasing for me. All right, and then I'm going to create some wires for the rest of our pins. All right. Go ahead and save that. So now we are done with our schematic. However, before I move away from the schematic, there's a couple kind of just nice, tidy things to do that I would like to make our schematic look a little bit cleaner. For example, here is some schematics that I've done in the past, and you'll notice that it's really nice to do kind of a little bit of labeling on things, and kind of boxing off different kind of areas of it. The only reason is it's just kind of nice to look at, and also helps the next person who's looking at your schematic to understand a little bit better what's happening. So I'm going to kind of block all the connectors off and make a kind of area for them, and then have the motor drivers be in a little bit of a different area. All right, so I'm going to create a little bit of text right here to talk about our V battery. So I'm going to say voltage for battery VM is motor voltage which is connected to a 2S LiPo battery. Let's make a little. And then I'm going to make something a little bit above it. And then note plus VM is 7.4 volts, no meal. And then I'm going to make this one just a little bit of different color so it's easier to read. Make it a little bit larger. So these are nice things to do just so the next person who is coming in and looking at your schematic has a little bit of a better understanding of what's happening. And also it's nice if you come back to the project way later on, you're like, I kind of forget what's happening here. So I'm just going to say other, I'm going to do P1 through 3 can be 2.54 millimeter header pins or JST. And I said P1 through 3 because we can see that the designators right here are P question mark. And after I annotate it, this one will probably be P1, P2, P3, or something like that. All right, so let's go ahead and box this off. We can right click here and we can use this rectangle and kind of box off this area. And then let's get rid of the fill, change the border to be small. And let's move this whole thing up a little bit and then add one last string of text down here, just designating what this box is. These are connectors. Let's increase the size a bit so people can see it. All right, so let's do the same for up here. I don't think I need to really note anything like this on these ones, but if you would like to, you can absolutely add any notes of your own up here. So I'm going to kind of create another box. And then I'm going to use this same font size and change this to be motor drivers. Did I spell driver wrong? Drivers. Okay. So yeah, this is the schematic here. And if you'd like, you can also add a little title and your name and the version of it. So let's go ahead and do that. Title, this is 2 motor breakout board. Yeah. All right. Motor drive. I'll change that. You can make it anything you want. This is where you would set your revisions. So, for example, since this is our first one, you can say revision, 00 or 0.0 or revision A, since it's the first one. There's a couple different ways to do it, but personally, I'm going to do revision A since this is the first time we're actually, yeah, so this is the first time we're doing it, and then next it would be B, C, if we make any changes to it. And then lastly, you can add your name. right, so let's go ahead and save this. And then before we move on, let's see if we made any kind of big mistakes in our schematic. Altium has this nice feature that allows us to kind of do some checks on our schematic. So let's go ahead and right click the project file and then click validate PCB. Ooh. There is. So we did get some errors that we need to take account of, as well as some warnings that aren't as important. So for the errors, it mentions that there's duplicate C's, P's, and U's, and that is because we haven't annotated everything. As I said before, everything is C question mark, C question mark, U question mark, and so on and so forth. So let's go ahead and fix that. Altium has an automatic annotation tool that we could use. So if we go into Tools, Annotation, we have a couple different options here. Annotate schematics opens up this big thing that you can kind of adjust exactly how it annotates. However, if you just want them annotated, you could do annotate schematics quietly and it'll kind of just do its auto settings. Click yes. And now everything has annotations. So C1, C2, U1, U2, and moving forward. So we were able to catch that error before we moved any further, which is nice. So let's see if there's any more kind of errors. Ooh. Ground contains output pin and power pin objects. Oh. So the kind of objects for these, this is due to the fact that Altium has some features that are nice for, so for example, you see those little arrows like this? Those indicate an input or an output. And it might mention that, hey, none of these have a driving source, so it can't be an input if there's nothing driving it, like a voltage supply or something. But in our case, we're going to have it being driven by over here from these pins. So it doesn't really matter. And the net ground contains multiple output pins. So I think that's just telling us that these are connected. So pin 1 and pin 7 are connected on both of these, which is fine. Remember, if we went into the data sheet, we can just hook up I send to ground. So it's just warning us, hey, did you mean to connect those two? Because if you accidentally connected those two, then you would want to make sure that you got that fixed. But in our case, we did mean to connect those two, but it's nice to be able to go through here and see that it let us know, just in case we accidentally did connect those two and we didn't realize. So let's go ahead and save this, and now we can create our PCB. So we want to go back to our project file over here, right click it, click add new to project, and then PCB. So this will open up this document right here, which looks really similar to that PCB footprint kind of editor that we were using before. It's completely empty right now because we haven't added anything in. However, we're going to go ahead and import everything from our schematic into this PCB file right here. So to be able to do that, we first need to save and kind of name this file. So I'm just going to do Control S to save it. And I'll just name it motor brake PCB. All right, so now that we have this kind of saved and noted, we need to add all of our components. And to do that, we're going to go into Design and then click Import Changes from the schematic, or the kind of import changes from the other one right there. So now all we need to do is look over this and make sure everything is good and just click Execute Changes. Close. And now we have all of our components over here. And if we click 3 on the keyboard, we can again go into our 3D model thing, and we can see here is our pins, here's our connector, and here are the chips and the capacitors. So that's everything we need. However, our PCB actual kind of layout is huge. We don't need that big of a PCB layout. So before we move forward, we're going to kind of just create a loose PCB layout and make it smaller size. So to be able to do that, you want to press 1 on your keyboard, and that will bring kind of this layer manager right here. And then we want to go to Tools, or actually Design. And then we can do Redefine Board Shape, and this will bring this up, and then we can draw a new board shape. I'm going to press G and increase my grid space to be the biggest. And just kind of make a board. Let's say everything is in mils. Let me press Q to change it to millimeters. Let's make a board that's here. Design, redefine board shape. So from right here, let's make a board that's, let's say, 30 millimeters by 30 millimeters. And we can change this in the future. I'm just making this for now. And then once you're done, you can press Escape, and then you will have your board kind of set up there. So I'm going to press 2 again to move back to this and move all of our components over here. And it looks like I probably made my board a little bit too small. But we can test it out. Yeah, that looks a little small. For all of our components, maybe can have a very tight board. But yeah, the next thing would just kind of be roughly placing components. Yeah, this is a little small for my liking. So we can go ahead and increase the board size and place all of our kind of components. So if you would like, you can continue this and try to create your own PCB over Thanksgiving break. And then we can review it next time that we're in class. So for now, that's going to be all we had planned for today. And then next time, we're going to be actually doing our layout on this. All right. Thank you.